Welcome to another tutorial of Proflan YouTube channel. In this particular video, we're going to have a discussion on how you can be able to work out the perimeter of the shaded region, and thereafter we're going to work out the area of the shaded region. Whenever you are working out area of a sector, when you are given the angle in radians, you need to remember that area is a half r squared theta, and whenever you are working out arc length, you need to remember that the formula is r, which is r is the radius times theta, which is the angle in radians. Now, for instance, suppose you are given a question and a sector is given like this. This is a very common question that you're gonna find. That if you want to work out the area of this sector, you are going to apply this formula, area of the sector, whereby this angle is actually theta, and this represents the radius, and this represents the radius. So that's something that you need to remember. Any given point, you are given area of a sector like this. But now suppose this part is subdivided in that you are expected to work out the area of the shaded part. You need to remember that this part that we have here is actually a triangle, and this part that we have here is called a segment. So meaning that for you to work out the area of a segment, you need to work out the area of the entire sector, and then you subtract the area of the triangle so that you can be able to remain with this part that is shaded here. So we can say, therefore, area of segment is going to be given by what? Is given by area of sector minus area of triangle, right? For you to work out the area of the segment, you need to work out the area of the sector, then you subtract the area of the triangle. Area of a sector is a half r squared theta. Area of a sector is a half r squared theta, minus area of a triangle is a half r squared sine theta. Where are we getting that from? Remember, area of a triangle is going to be a half AB sine theta, whereby A and B are those lines that are forming that particular angle that we have here. So, but R and R, so it's going to be r squared sine theta at this given point. So let us now dive in and go back, work out this question, and see what you're supposed to work to do in order to find the perimeter of this shape. If you are new to Proflan YouTube channel, consider subscribing so that anytime I'm going to upload further tutorials, you'll be notified. Proflan YouTube channel is a place whereby you can be able to find matters physics and math for both IGCSE and A level. So if you are taking Cambridge, you are taking Edexcel, this is your place, because you're gonna get all the tutorials involving the two subject, math and physics, IGCSE and A level, so you can be able to learn and ace your grade. So now, in order to find the perimeter of this shaded region, we need to know what this arc length is. We need to know what this arc length is. So we are going to call it arc length S, so we can be able to find it in order to work out the perimeter. Number two, we need to know what, because this radius, circle center O had a radius of 6 centimeters. The radius was given as 6 centimeters. So which means that we have all the right reserved for us in order to work out this question, because we need to know this arc length, we need to find this distance here, right? We need to find this angle at this given point. How are we going to find this angle here? Is the fact that we're going to use the property that a radius, this part is also 6, is going to form 90 degrees with the tangent AB. So which means that this angle on this side, we can call it angle beta. We can be able to find it, and then it will enable us find this other angle on this side. So before we look into that, let us find angle beta. And since this angle is opposite to this side and adjacent to 6, so we can now say tan beta is equals to opposite over adjacent. So this is going to be tan beta. Beta is just a symbol to represent an angle like theta. We are going to say opposite is 8 over adjacent, which is 6. So which means that beta is going to be equal to the tan inverse of 8 over 6. So if we work out this, let's see what we are able to get. We are going to substitute this 8 and this 8 into the formula in order to work it out. Remember, we are going to say this is a tan inverse of 8 over 6. If you work it out using your calculator, you're gonna get the angle in radians. This value is 0.93. So we are going to say this is 0.93 radians. So which will mean that once we have this as 0.93, we can be able to work out the value of this angle on this other side here. Because this is a straight line, then we can say now this is going to be our angle theta. So theta is going to be pi, which is 180 straight line, minus 0.93. If we work it out, this is pi minus the answer, we're going to get 2.21. So this is 2.21 radians. So the angle that we have at this given point is 2.21 radians. So meaning that for us to find the arc length, we can be able to apply the formula. Arc length S is going to be R theta. So which is going to be 6 times 2.21. If we work it out, I'm going to put this in the calculator, then this is going to be 6 times 2.21, which translates to 13.26. 13.26 centimeters. That is now this particular part. So next, we need to know what is the length of AO. Remember, this is a right angle triangle at this given point. So we can be able to use Pythagoras theorem in order to work out AO. So we can say AO is equal to the square root of, this is a shorter side, this is a shorter side, so AO is a hypotenuse. So we're going to say this is going to be 6 squared plus 8 squared, which is equal to the square root of 36 plus 64, which is equivalent to 100. Square root is actually 10 centimeters. The square root of 100 is 10, so meaning that this dimension here is given actually as 10 centimeters here. But for us to find perimeter, you need to remember that perimeter is distance or round. So meaning that in order to work out this perimeter, we're going to say perimeter is going to be this part, we got it down up here, which is 13.26 plus this part 8 centimeters plus 10 centimeters, then plus 6, because now up AO is 10 plus 6, which is the radius, plus 6 at this given point. Let's see what we are going to get. So that is actually 13 plus 8 plus 6, then plus 10. I'm getting my value as 37.26. This is 37.26 centimeters as the perimeter. Okay, now once we have this perimeter, the next question of interest at this given point for part B is to work out the area of shaded region. Now, in order to work out the area of this shaded region here, I'll decide, work out the area of the right angle triangle, then add the area of this particular sector I have at this given point. So I'll add the area of the triangle, then I add the area of the sector. But remember, area of the triangle is going to be, this is a half base times height, because this is a base and this is the height. We have 90 degrees at this point. We're going to say a half base times height plus, I'll work out the area of this sector that we have in this part. The angle, we had gotten 2.21. So we're going to have a half r squared theta. So I'll say a half times 8 times 6. I'll work out that, and then I'll say a half times 6 squared, because the radius of this sector is 6, then times the angle, which is 21, rather the times the angle, which is 2.21. Then I'll enclose like that so that we can put that information in the calculator. So I'll say this is 1/2 times 8 times 6. I'll close the bracket, then plus open bracket 1/2 multiplied to 6 squared multiplied to 2.21. So I'm going to get my answer correct to 4 significant figures. My answer is actually 63.78. So the answer here is equals to 63.78 centimeter square. So basically, that's what you're supposed to do in order to work out questions like this, right? If you are new to Proflearn YouTube channel, consider subscribing so that anytime I'm going to upload a tutorial, you'll be notified. In this question here, we are supposed to work out the perimeter and the area of the shaded region. The information that was provided in this question is that O is the center of this circle. So O represents the center of this circle. So you can say this is a circle of center O, and the radius of this circle is 10 centimeters. AB is 15 centimeters. DC is 10 centimeters. So how are we going to work out this question in order to work out the perimeter of the shaded region and the area of the shaded part? So for us to work out this question, the first thing that we need to identify is that we can be able to join OB and also join OA like that. So since we are told that the radius of this circle is 10 centimeters, so we can say this is actually 10 centimeters, and this point is 10 centimeters, because both of them are representing the radius. So if we drop a perpendicular right from this given point, if we drop a perpendicular, let me just try to draw a perpendicular here. If we draw a perpendicular right from this given point here, we are going to have 90 degrees at this point, so that this is going to enable us work out the size of this angle. Then if we know the size of this angle here, we can multiply by 2 so that we can be able to get the size of angle A or B. So that's what we're going to do, so that we can be able to work out this length here, and also we're going to find this length. then because we will be able to work also the circumference of this circle so that we can be able to subtract and get what this part is. So first, let's find this angle theta. Angle theta here, let me just write it properly. Angle theta is going to be what? We have this 10, then if this is 15, the entire of it, this line from the center is going to subdivide this into two halves. This is going to be 7.5 and this is going to be 7.5, because a perpendicular line to the chord from the center of the circle is going to subdivide this chord AB into two equal halves. All right, so we're going to extract this triangle, right angle triangle here. This is 10 centimeters. This is 7.5 centimeters. Then we are finding this angle at this point, which is theta. Of course, this is 90 degrees. So which means that we can now say, because we are having hypotenuse and opposite to this angle, then we can say that this is sine theta is equals to opposite over hypotenuse. So you can say sine theta equals to opposite, which is 7.5, hypotenuse, which is equivalent to 10. Then we can now say our theta is going to be equal to sine inverse of 7.5 over 10 at that given point. So which means, and I'm going to work out this angle in radians so that we can be able to work it out. I'll work it in radians. So this is going to be sine inverse of 7.5 over 10. So if I work this out, I'm getting my angle in radians to be 0.848. So I'm going to write it correct to two significant figures. So this is 0.85. This is going to be 0.85 radians. Then to find angle A or B, this is going to be 0.85 times 2. If I multiply that times 2, I'm going to get my answer as 1.7 radians. That is actually the entire angle now in this regard, this angle at this given point. So which means that once I have this angle, I can be able to find arc length AB. Yes, so we can be able to find now arc length AB. So remember, the objective of this question is to work out the perimeter of the shaded part, and the perimeter of the shaded part is going to be AB plus this part here plus this part which is CD plus DA at this given point. So what I'm deciding to do, I'll find this arc length, here, using now this angle that we have obtained. So I'll say arc length, I'll label it as AB. Arc length AB is going to be equal to R theta. Remember arc length, remember the arc length of remember the formula for arc length is given by S equals to R theta. So meaning if I'm finding this arc length here, I'll say that's going to be equivalent to the radius 10 times 1.7, which is going to be 17 centimeters. So that's the arc length, 17 centimeters. So this part we can say that is 17. Now the other measurement that I need here is to work out this arc length down here. I'll work out also this arc length down here. Yes, I'll call it arc length S, that is a DC. Now, in order to work out that arc length, something that you can bear with me is that I need to know what this angle is, this angle here. So I can be able to join like that, and I can be able to join at that point. So of course this represents the center. Or so how are we going to find this angle here? What's the value of this angle here? What's the value of this angle here? Remember, we were told that the radius of this circle is 10. So this is 10, this is 10, and this is 10. So meaning that this is an equilateral triangle below here. This one, this one, this one are actually equal. So meaning that each angle is 60 degrees. And then it means that this is 60 degrees. So in radians, we know that 180 equals to pi radians. What about 60 is equals to what? So this implies that this is 60 over 180 times pi, which is going to translate to 1 over 3 pi. So which means that this angle here is 1 over 3 pi. So I can be able to use 1 over 3 pi in order to find this arc length below at this given point, right? So I can be able to say now arc length is actually r theta. So in that case, I'm going to say r is 10 times the angle is 1 over 3 pi. So which is going to be equivalent to what? So if we work out this, what do we get? Let me just try to work it out. This is 10 times 1 over 3 pi, which is actually translating to 10.47. 10.47. Yes, 10.47. Rounding off, okay, that is 10.47. So this is actually 10.47 centimeters. So down here we're having 10.47 centimeters. Now remember, we had said we want to work out what this part is and what this part is. Now to do that, we are going to find the area. We are going to find we're going to find this circumference of the entire circle. Then we subtract the sum of these two. Yeah. So we are going to say circumference is actually pi d, which implies that circumference, in this case, circumference is going to be pi times 20. So this is going to be 20 pi. And what is the value of 20 pi? 20 pi is equivalent to 62.83, which is equals to 62.83. So that means that the entire part is 62.83. So what will be this part here and this part here, which is AB and BC? So we're going to say now 63. So I can see now I'm running out of space. So I'll say 62.83 minus the sum of this and this. So this is actually 17 plus 10.47. If I work it out, 17 plus 10.47, I get my answer as 27.47. All right, so I feel I don't need this part now. I believe you've been following what we did there. All right, so I'll transfer that 62.83 minus the answer I've gotten. This sum here is giving us 27.47. So if I subtract that 62.83 minus answer, I'm getting my value as 35.36. Now this is 35.36 centimeters. 35.36 centimeters. So that 35.36 centimeters represent this part and this part here. because we had gotten this section and this section, we added them together in order to get what we are going to subtract from the entire circumference of this thing. So we have gotten that part. So therefore, perimeter is going to be equal to, we shall add this part, which is 15 plus 35.36 plus 10. So if we add all those, we're going to get what? 15 plus 35.36 plus 10, which translates to 60.36 centimeters. Now the next concept we are going to do, or the next part that we need to do, is to work out the area of the shaded part, area of the shaded region. Area of the shaded region. Let's see what we can do in that case. So this is actually C. We have C at this point. Then we need to work out now the area of the shaded part. What do you think we are going to do in order to work out the area of the shaded part here? Area of shaded region. Now, in order to work out the area of the shaded region, my approach will be, I'll work out this is actually 15 centimeters. I'll work out the area of the white part and the area of this white part. I subtract them from the area of the triangle. What did I say? I'll work out the area of the white part and the area of the white part. I add them together. Then I work out the area of the entire triangle. Then I'll subtract the white parts that I worked out. So meaning that this white part represents the area of a sector. So meaning area of a sector, area of a sector equals to, how do we find the area of a sector? Area of a sector is area of a triangle. Now, to find the area of this white part, we are going to say area of segment is going to be, because the white part actually represents the segment, is going to be area of a sector, which is a half r squared theta, minus area of the triangle A or B, which is going to be a half AB sine theta. So in that case, we are going now to say that area of a sector is going to be a half times the radius, which is 10 squared, times the angle. Now the angle that we're going to talk about here is the angle of the entire part here, which is actually 17. We had gotten that angle as 17 from, no, rather 1.7. We had gotten this angle as 1.7. So meaning that this is going to be 1.7 radians. So we shall work out that there. Then plus a half AB. A and B are these sides that are forming this angle for the triangle. So this is going to be R times R. So this is going to be 10 squared sine 1.7. So also we're gonna work it like that. So if we work it out, what are we going to get? Because we are going to write exactly what we have there. This is going to be 1 over 2 times 10 squared times 1.7, which is going to be 85 minus, we have a half times 10 squared times sine of 1.7. Also, if I work out this, I'm getting 49.58. So this is going to be 49.58, which means that if I subtract 85 minus 49.58, I'm getting my value as 35.42. So this is 35.42 centimeter square. And this area is actually representing the area of the white part here. Then I'll work also the area of the unshaded part down here, which is also going where I'm going to employ the same approach. I'll find the area of the sector, then subtract the area of this triangle so that I can be able to get the area of this white part also. So we are going to say area is going to be a half times r squared, which is actually 10 times 10 times the angle, because we are using actually this formula here, and times the angle, which is a third pi, subtract a half times AB sine theta. So this is going to be a half times 10 squared sine pi, third pi. So if I can work it out and put it in the calculator so that I can be able to get the answer direct. And if you are new to Proflan YouTube channel, consider subscribing because more is yet to come. So this is going to be 10 times 10 times 1 over 3, actually pi, then subtract a half times 10 times 10, that is 10 squared, times sine over 1 over 3 pi, like that. All right. So if I work it out, I'm getting 9.06 as our answer here. This is actually 9.06 centimeter square. So which means that we are going to add 35.42 plus 9.06, which is going to give us 9.06 plus 35.42. This is giving us 44.48. So once we have that, we are almost home and dry. We need to work out the area of this circle. So we can now say we can work out the area of the circle. Let me just use this space at the top here so that we can be able to find that. So area of the circle is going to be pi r squared, which is pi times 10 squared. If we work it out, I'm going to find what? I'm finding my answer is 314.16. 314.16. That is the area of the entire circle. Therefore, area of shaded region is going to be equivalent to the area of this part subtract the area of this part. So we're going to say this is going to be 314.16 minus 44.48. If you work it out, you are going to get your answer as I'm getting my answers 269.68. .68 centimeter square as the area of the shaded region.